Hey, Vsauce, Michael here, and my tea is quite hot, but it's not the hottest thing in the universe. So what is? I mean, we know that there is an absolute zero, but is there an absolute hot? A point at which something is so hot it can't get any hotter? Well, to find out, let's begin with the human body. Your internal temperature is not constant. 37 degrees, 98.6, sure, but those are averages. Your body's internal temperature fluctuates by about 1 degree Fahrenheit, half a degree Celsius, throughout the day in a cycle. Assuming you sleep at night, at 4:30 in the morning, your body reaches its coolest, natural, healthy temperature, and at 7 p.m., it reaches its highest. But a dangerous fever is not good. 108 degrees Fahrenheit is almost always lethal. The highest recorded air temperature across all of Earth has happened 4 times in Death Valley, where it has reached 129 degrees Fahrenheit. 180 degrees Fahrenheit is the recommended temperature for water when brewing coffee, and at 210 degrees Fahrenheit, a cake is done. 2,000 degrees Fahrenheit is the temperature of lava fresh out of the ground. But come on, make your own lava like Green Science Pro. This guy uses Fresnel lenses to focus the sun's energy onto whatever he wants. This is a small piece of obsidian, volcanic glass, which he can melt into actual lava right in his backyard. Keep in mind that the sun is having that effect even though it is 93 million miles away from Earth. Right up on the surface of the sun is a different story. The surface clocks in at 10,000 degrees Fahrenheit, but the center, where fusion occurs, is ridiculous. Temperatures there reach 28 million degrees Fahrenheit, which is also known as 15 million Kelvin. The Kelvin scale has units that are the same size as a Celsius degree, but it's an absolute scale, where 0 is absolute zero. When matter reaches temperatures as high as those found in the center of the sun, an enormous amount of energy is radiated away. If you were to heat only the head of a pin to the temperature of the center of the sun, it would kill any person within 1,000 miles of it. Speaking of which, the energy emitted by an object often tells us a lot about the temperature of that object. Any object over absolute zero emits some form of electromagnetic radiation. You and me, we don't glow visibly, but we do emit infrared light. We can't see it, but infrared cameras can. WBD has great videos, and here he is hiding inside an opaque black trash bag. Now, we can't see him, but his body is infraredly glowing through it. If you want something to be the right temperature to glow in the visible spectrum, you'll have to reach the Draper point, about 798 Kelvin. At this point, almost any object will begin to glow a dim red. We can calculate the expected wavelength of radiation coming off of an object because of its temperature, and that wavelength gets smaller and smaller the hotter and hotter the object gets. It goes from radio waves to microwaves, up through infrared to visible, all the way to X-rays and gamma rays, which are created in the middle of our sun. At temperatures as hot as the sun, matter exists in a fourth state. Not solid, not liquid, not gas, but instead a state where the electrons wander away from the nuclei. Plasma. If you've watched my temperature lean back, you know that you can make plasma by microwaving fire. But don't do it. Besides, our sun isn't even close to being the hottest thing in the universe. I mean, sure, 15 million Kelvin is pretty incredible, but the peak temperature reached during a thermonuclear explosion is 350 million Kelvin, which hardly counts because the temperature is achieved so briefly. But inside the core of a star, 8 times larger than our sun, on the last day of its life, as it collapses in on itself, you would reach a temperature of 3 billion Kelvin. Or if you want to be cool, 3 gigakelvin. But let's get hotter. At 1 terakelvin, things get weird. Remember that plasma we were talking about that the sun is made of? Well, at 1 terakelvin, the electrons aren't the only thing that wander away. The hadrons themselves, the protons and neutrons in the nucleus, melt into quarks and gluons, a sort of soup. But how hot is a terakelvin? Frighteningly hot. There's a star named WR104, about 8,000 light years away from us. Its mass is the equivalent of 25 of our suns. And when it dies, when it collapses, its internal temperature will be so great that the energy emitted, the gamma radiation it flings out into space, will be stronger than the entire amount of energy our sun will ever create in its entire lifetime. Gamma ray bursts are quite narrow, so Earth is most likely safe. But what if it wasn't?